I'm not ready to pass back Unit 9, okay, because I've got a lot of people that need to take it. Maybe Thursday. If not, it will be next week. But the window to do retests is still 2 weeks away. So that means if we are able to go over at the end of the week or early next week, you still have tutorials before that retest window opens. Trying to get makeups done this week, but it is a short week and we have Monday off, so it's kind of a mess. Be aware though that retest window is going to be open the same week as your next test. So as we're going to keep learning new stuff, we're starting new stuff today. The next test, this will take us all the way to spring break. I don't exactly know what we're doing right there, but we'll get there. Yeah, there's the school day SAT. I think that's just juniors. I don't know what the afternoon looks like. I don't know. Anyways, I just wanted to put like where the quarter ended so you kind of had an idea of what's to come. So we're getting close. We're going to have 2 more grades left in this quarter. Unit 10, I personally think is easier than Unit 9. It's about rational functions still. However, we're talking about their graphs, and their graphs are kind of crazy. Normally when we graph something, we do like 1 day of graphing and it's over. This is a whole unit on graphing because it's just the math behind it is not hard per se, but it is kind of a lot of information because there's just a lot of different things going on with these graphs. They're really weird. So we're splitting it up into a few days, but just know it's going to be kind of heavy. Not so much today, but it's going to be kind of heavy next class just to get through. Here's how we find all this stuff. But then actually like finding stuff isn't that hard to do mathematically. It's just a lot of information to process. And then we'll get into the graphing, a little bit of writing. So you can kind of see how it's laid out, but that's that. So we got a new notes packet for you. There's going to be a new practice packet. Good news, there is room to actually work your problems in the packet because it is graphs and all those things. So you don't have to have separate paper, but you do need to keep up with both of these pink packets. Should you ever lose anything, let me just show you. It's all linked up here in Canvas, okay? And then, I've got hard copies in here. But that's that. Stay tuned on the Unit 9 stuff. Pencil in when the retest is if you're planning. Know you're already planning to work on that. But give me a few days to get these makeups done before we go over stuff. All right. So, here we go. Page 1. We're going to spend an entire unit on these rational graphs. Shh, y'all pay attention, okay? They are a little bit weird. They're like graphs you've probably never really seen before. There's a lot of vocab that we have to go over. And then the next 2 lessons are going to be about how do we find this stuff. We're going to sort of focus our efforts on transformations more so today. And next class will be like, okay, if we're not in transformational form, what do we do? But then we're also going to kind of just take a little sneak peek of what some of these graphs can look like and talk about attributes there. So there's a lot of vocab and stuff today. But again, the algebra behind it, like y'all have suffered through all the algebra of rationals. Really, at this point, it's not too bad mathematically. It's more just like understanding what you're doing here. So these are our graphs, are our rational parent functions. I'm going to label these here. Rational parent functions. There are 2, but we're really going to only focus on the odds. But technically there is an even one, just to familiarize you with that, of what that could look like. But the odd parent function is the graph y equals 1 over x. So again, what makes it rational is it's a fraction. X is in the denominator. We know that there are restrictions on your domain when x is in the denominator. That's going to kind of carry over. And now we're going to talk about what does that mean in the graph and what's going on there. So these graphs kind of look like, I call them like boomerang shapes. They've got, a lot of times they're kind of like opposite quadrant boomerangs. This is your parent function that we're going to be transforming today. This one is not opposite quadrants because it is even. That's why they're kind of pointing up together like that. But you've got a lot of vocab here. So we went ahead and typed it all out for you. But I'm just going to kind of go through and hit the high points, and then we'll fill this out based on these graphs here. So x-intercepts, those are going to be something that we kind of already know the definition of that. Yes? Yes. Does anyone else have a pencil that's closer to him? Or do you need to come get me? Thank you. X-intercepts are things that I mean, it's where the graph crosses the x-axis. It's going to be like written as an ordered pair. So it'll be an x value and the y value will always be 0. The thing with the functions that we're going to graph today, if you have one, you may have one, you may not. If you do, you can have multiple, depending on how complex your graph gets. But that's something that we will be finding are our intercepts over the next couple of days. The y-intercept, this one, there can only be one. If there is one, again, you may not have one, depending on what's going on with the graph. It is an ordered pair as well, and it will be written 0 and then whatever your y value is. New vocab that you may not know so far. I know you've seen this word before in Algebra 1 because we talk about it in Algebra 1, and then we laugh about it because it's a funny word, but asymptote. Okay, so these types of functions have horizontal asymptotes as well as vertical asymptotes. You got both going on here. And these are really, really important. These are kind of like what guide how you do your graphs. They're always the first thing that I put on a graph. Like when I'm graphing, I will use my highlighter and draw those in. So if you have a highlighter or a pen or something, you might want to get those out because we are going to be graphing a lot. But these are... they're breaks in the graphs. They're like boundaries. Okay, so horizontally, it's a line that the graph of the function approaches as x gets really, really big or really, really small. By definition, that's what your horizontal line is. But basically, it's a boundary line that your graph is like leveling off to horizontally. Okay, so I'll look at this parent function right here, and I can see that my graph, my boomerang shapes, are leveling off towards the x-axis. So that line right there represents my horizontal asymptote. Okay? Now, we have to write it because it is a line. We have to write it as such. So these are going to be written as y equals, and then you're going to write whatever number that you're leveling off towards. If you don't write it as y equals, you're going to get it wrong. It's a line. You have to write it like that. And that's what your horizontal asymptote is. But it's basically saying, hey, if you go really, really big x's or really, really small x's, where's your graph leveling? That number. Your vertical asymptote, it's a vertical line. It guides the graph of the function, but it's not actually a part of it. It cannot be crossed. It happens where the x value is not in the domain. So your vertical asymptote, what's going on right here is a domain restriction. Just like we found, and if you remember how we found them on your last test, when we did solving, that's where the values in the denominator could give you a 0. Okay, and so that's going to result in a vertical asymptote. It's like problems, undefined, not working. Okay, it's a break in the graph again. It is a line. It's got to be written as x equals because it's a vertical line. Okay, so on this parent function, my vertical asymptote, and again, the parents are pretty boring, so they're both just x equals 0 and y equals 0. The more complicated we get with these graphs, which really we're not going to touch too much on the algebra of complicated graphs today. You'll see some complicated graphs at the end and need to be able to pick this stuff out from pictures. But there can be crazy stuff. You can have multiple vertical asymptotes. There's different cases for what your horizontal asymptote is. But again, it's just something we need to get ourselves familiar with, know how to write it, and then we'll spend the next couple days talking about how to find it. One thing that I think helps people memorize, because there's a lot of memorization in this, how to write these that I have been saying is hey and vax, like this. So your horizontal asymptote, I abbreviate that because that's just a lot of letters and a lot of writing that I don't want to do. So HA, and then that's always going to be written as y equals. So I will say that might help you. Hey, it's got to be y equals. And then your vertical asymptote, again, it's an abbreviation. Those have to be written as x equals. And that seems to help people that just when you see it, you can go ahead and fill that in. Y equals, x equals, get that out of the way. And then the last two vocabulary words are domain and range, which, again, we already know what that is. The domain is the possible x values that your graph can have. So you'll have some stopping points here because of these asymptotes and something else that we'll talk about. And then same thing with your range. we really won't have you find range on anything other than transformational form because potentially crazy stuff can happen if there's multiple vertical asymptotes. So range is kind of specific just to these. So looking at all of that, take these two parent functions and try to fill in these blanks right here as best you can, and then we'll go over it in a minute. Talk about the rational odd parent function first. Is there an x-intercept? No. Is there a y-intercept? What about the even one? Is there an x or a y-intercept there? No, not with these parents, okay? So you're going to have none and none there. For your asymptotes, again, the parents are really boring. So the asymptotes are just x equals 0 and y equals 0. Make sure you know which one goes with which. Hey, VAX. So y equals 0 is your HA. X equals 0 is your vertical asymptote for both of these. So these are breaks in the graph, okay? Again, very basic. Here's how I'm going to give you two ways that you can write your domain and range. And there's one that I know you're going to like better because it's faster and I'm all about efficiency. But I want you to make sure that you know both definitions just to be sure. So we'll do the longer one, then we'll do the shorthand after that. So the longer one the one I'm going to write first is your interval notation. So basically when you look left to right, again, domain is the possible x's. Your graph is going forever to the left. And what number represents forever to the left? Negative infinity. And it's just going until it gets to, there's your break. Your vertical asymptotes are going to be one thing that breaks your graph. So where is that vertical asymptote happening? At 0. So I have a break there. I can't equal. I will never cross that vertical asymptote. I will never land on it. So I'm going to put a parentheses right there. But then I pick back up and I have my second boomerang. So I'm going to open up a union and another interval. And that starts, again, very, very close to 0, but never actually equaling 0. And then it goes kind of and hovers along that HA towards what? Positive infinity. Okay? So that's one way that you can write the domain. The shorthand way, and I think the way that you will probably choose to do if you're writing it on your own, you need to know how to read this. But here's kind of the shorthand way. All real numbers except x can't equal 0. So you would just say anything works except for these domain restrictions, which you already know how to do domain restrictions. So it's whatever that can't be. And so your vertical asymptote has to deal with your domain. So wherever that VA is, then you're going to have problems in your graph. Okay? Your range, which we're really only going to do range today, has to do with the possible y values. Again, bottom to top. So what's the lowest y value that this graph is going? Negative infinity. And then it goes until it gets all the way up to the HA, which is at 0. But it doesn't equal it in transformation land. And then we go again from 0 to infinity. And you could write that shorthand, all real numbers, but y cannot equal 0. And again, that has to do with your HA. Okay? I won't ask you to do range pretty much after today, but if there's anything transformation, range is fair game. Okay? Just whatever that HA is. Domain's pretty similar for even. It's going to be negative infinity to 0, union 0 to infinity. But your range, however, is not going to be the same because do you ever approach negative y values with this graph? So you could say either 0 to infinity not included, or you could say y greater than 0. I don't know, a couple different things. We don't do too much with evens after really just looking at it today. So there we go. Let's talk about parent function points for this graph right here because we like to do transformations with our parent function. Really, once you have your asymptotes, those are your boundary lines. There's only 2 points that I need you to grab. And that point is positive 1, and negative 1, negative 1. So once you kind of get an idea of where, what side of the boomerang or what side of asymptotes your graph's going to go, you can just transform those points and then you just kind of hug the asymptotes, graphing them wise. We're not going to get too specific with points with these, but we need to know where our boundaries are. questions. All right, your favorite letters again. Here they are. A, B, C, and D. Haven't seen these in a while, have we? Do you know them still? That is a lie. You have seen them before. You have seen A, B, C, and D. You definitely have. You haven't seen them in this type of function, no. But you know A, B, C, and D. Those are the same things. Okay, you haven't seen that function, not yet. Okay, so A. A is either in the numerator. I think that's the most common. Y'all can technically put A in the front, but it's still, as far as like, this one's a little bit different with like the inside and outside thing. It's more of, is it in the denominator with the X or is it not? Okay, so like D is clearly outside the fraction, A is above, but anything inside is going to be kind of in that denominator with the X value. So we'll go through this real quick. A can do a couple of things. If it's negative, what does A do? Negative in the numerator or negative in the very front? No one remembers. It's a vertical reflection. I always say reflect over X. Reflects the X axis, but you are correct. It is vertical. I'll do VR. Okay? It's going to flip your graph over. Then we have to talk about the number A itself. Okay, so if the A value is greater than 1, then that is a vertical stretch. If A is between 0 and 1, then it's a vertical compression. You can abbreviate with these. Technically, there should be absolute value bars around these A's. What does that mean? You're just looking at the actual number itself. The negative does the reflection. Other than that, you just actually look at the number, like what is it? Is it bigger than 1 or between 0 and 1? Okay? We'll talk about B in a minute. What about C? Effects of the C value. Left and right. If it goes to the left, what kind of sign's in front of it? A plus. Plus C means you move to the left. Minus C means you move to the right. Okay? Here's a big idea about the C value. The C value is going to change your vertical asymptote, and it's going to restrict your domain. Okay? So your vertical asymptote, you should be able to look at a function in transformational form and know that it's going to be x equals whatever that number is. That's worth highlighting, okay? So it'll be down there. It's got to be the opposite sign. So if you see in the equation, they usually put it as x minus c. That's why I put a positive c right there, because it's a sign flip. So you can see that there, okay? The D value, will move your graph vertical translations. And it's normal. So if it's plus, then that means your graph goes up. If it's minus, that means your graph goes down. This value is going to change your horizontal asymptote, and it will restrict the range. Again, shortcut for you, your HA is y equals whatever number that is. So again, when you're in transformational land, which we're really only going to be in today, okay? Next class we won't be in transformational land. But you should be able to see those asymptotes just in the equation. We're going to talk about B. We're not really going to do too much of B values here, but remember B has to be factored out. Must be factored out. It's down in the denominator versus A is in the numerator typically, or the very front. I don't really ever write it in the very front. I always put it in the numerator. Yeah.
So if it's say C is -2, so then would the vertical asymptote be 2?
Positive 2. If your B value is negative, I do think we have one of these, but that's a horizontal reflection or a reflection over the y-axis, and I'll write HR. And then remember, your B values kind of do the opposite thing. So if the absolute value of B is greater than 1, then it's a horizontal compression. And if it's between 0 and 1, it's a horizontal stretch. These transformations aren't going anywhere. We've got rational transformations, and then we've got exponentials and logs. So we still have 2 more lessons over transformations before the year's over. I don't know if I'll be teaching both of those. Depends on when I'm leaving. So remember, here is your rule for your tables, because we're going to be making tables there. B and C are always opposite, so you'll do, if you have a B value, you'll do the reciprocal of it. The only thing that's not opposite is if B is negative. C, you change the sign, and then A and D affect your Y. Okay? So here we go. We're going to try a couple of these, and then we're just going to look at some identifying stuff from graphs. So here we go. Here's our function. List the transformations, do the tables, find the stuff, graph it. Okay? What I typically do first is, we can do our transformations first. We can list that. So 2 over x plus 5. This is rational odd, okay? I know that it's odd because the power of x is 1. There's not like an even would be like x plus 5 whole thing squared. And we're really not going to do even, so you don't have to worry too much about that. But what transformations are there? So this 2 in the numerator, is that an A, B, C, or D? That's an A. So since it's a 2 and it's greater than 1, that means it's a vertical stretch by 2. And again, I'm cool if you abbreviate. I'm not really picky about that, okay? All right, and then in the denominator, I have x plus 5. What is that 5? A, B, C, or D? That's a C. So what is that really doing? That's going left 5. Now, is there a D value there? What does that assume to be if there's not one? 0. Okay, so I'm going to write that there just for a second because that's going to help me with my asymptotes here. But if you don't have to write it there, then don't worry about it. But I want you to see where these are. So remember, hey, Vax, horizontal asymptote has got to be y equals, okay? And it's y equals whatever that D value is, which in this case is a 0. So my horizontal asymptote is y equals 0, okay? My vertical asymptote is the C value, and it's x equals, now C is always opposite, so if this is an x plus 5, my VA is at negative 5, okay? Get those down and then get them on the graph. This is going to help with your boundary lines. It's going to help you with your shapes, your boomerangs. Get those on the graph. So I'm going to negative 1, 2, 3, 4, 5. And for the graphs on your tests and stuff, I am looking, are your asymptotes drawn in correctly? Draw them in as a dashed line. I will do a color as well in case you can't see the highlighter. There's my vertical asymptote. Here's my horizontal asymptote. And these are my boundaries. Okay, do those very first. Very first thing, just put them on there. Now, we really only have you do 2 points from the parent function. If you remember, those were negative 1, positive 1, positive 1. I might have put the positives first, but whatever. Okay? And then from there, let's talk about, okay, how are you going to get your new points? Well, what's happening to my x's? Left 5, so I need to take each x value and subtract 5. Switch a sign. Y values, what do I do to those? Multiply them by 2. A value, A and D affect your y values. Only B and C affect your x's, and they're opposite. So negative 1 minus 5 is negative 6. 1 minus 5 is And then I'm going to double these, so this is -2 and +2. All right, so if I graph these, -6 is going to be 1 away from the asymptote and then 2 down. This one is left 4 and up 2. So this will give you kind of an idea. Remember, rational odd, they're supposed to be like opposite quadrants, okay? Like one will be in up here, one will be down here, but they could be like this as well. So if you kind of get those points on, they'll help you figure out which way they're supposed to go. And at that point, you're just going to use your asymptotes and just kind of hug along the vertical asymptote and then go out on the horizontal asymptote. Okay, so it kind of has to have that boomerang shape. So it's going to go up towards that. It's not going to cross. Do not cross a vertical asymptote ever, ever, ever. Horizontal asymptotes are their own thing, but for transformations, they hover above or below. Okay, so there's my first boomerang. I'm, again, using that boundary line. This is saving you from having to plug in more x values if you know how to use these correctly. And then this one, I'm going to hover under the HA and go close to the vertical asymptote like that. And so it has that shape, and I can see this is what I'm looking at here. So my domain can be anything except what? What can x not equal? -5. And here's what's helpful to remember that. Vertical asymptotes are written as x equals. Domain's always talking about x. So these numbers should always be matching. For range, it's anything except for what can y not equal? 0. And again, that comes from your HA. Okay? And we really only do range today. So there's your first graph. How do you feel? They're so fun. They're so pretty, and they are not hard to do ever. Yeah. Yes. I did that for sure. Yes. Okay, go ahead and try. Go to number 2. You're good? Okay, go to number 2. List out your transformations. There are 4 on this one. And then try to find your asymptotes first thing. Transformations and asymptotes. Ready, go. What transformations do we have? There's 4. Okay, one of them is up 1. Check. Right 5. Check. What else? Vertical reflection, or reflection over the x, and vertical stretch. That -4 is an A value if it helps you to label. This is an A, this is a C, this is D. We're going to see a B value on the last one. So there's your transformations there. Okay, oops, didn't mean to cover those, or to show those. What is your vertical asymptote? X equals 5. What's your horizontal? Y equals 1. Again, those come from there. Flip the C, just like always, as with a vertex, with an inflection point, with a starting point. C is always the one that flips. D does not. It just stays as is, okay? You honestly can probably go ahead and do your domain and range from here. All real numbers, but x cannot equal 5. All real numbers, y cannot equal 1, okay? And then this is still, like I said, we're just graphing odds. So your points that you start with are -1, -1, +1, +1. Get your asymptotes on the graph before you do any points. That's the first thing, first priority. Then you need to make your table. What is your table going to, and there are people that graph these asymptotes backwards. Like they say it's a horizontal asymptote and then they draw it as vertical. Like you need to know. You need to know the difference. That is not good. And then 5. What is your table going to look like? What are you going to do to your x values? Add 5. Good. What about your y values? Multiply them by -4 and add 1. X plus 5. Very good. I'm going to write the other ways to write your domain and range as well on my key, just so you can see. Try to fill those in real quick. If you're working ahead on 3, be careful. There's something extra on number 3. So again, make sure you're staying well within your boundary lines. You can see, because there's the reflection here. Do you see how these are they're still like opposite of each other, but they're not how the parent function was. That's because of your reflection. But they should kind of be opposite of there. Okay? And then I wrote my domain and range another way. I'm not picky about when you fill in, but there are going to be some times where like I give you a domain and you need to know how to read that, and I'm saying I could give you either form of domain. So just make sure you know how to interpret that. But basically it tells you whatever your asymptotes are, because you got stopping points there. Number 3 is the last graph that we're going to do. And then if you look at the rest of the notes, they're just identifying stuff from pictures that we'll talk through, so you can kind of see how crazy these graphs can get. And that's what we'll be focused on the next 2 days. But what you got to be careful about on number 3 is, what did we put on the denominator? We gave you a B value. What do we know about B values? They have to be factored out. So technically, I should be writing this as 2's, nothing wrong with that, over, but what do I need to do on the denominator? Negative, and then it becomes x plus 5. Now, you have to do that, okay? If you don't do that, then you're going to get a transformation wrong, and then you're going to also get an asymptote wrong. You know asymptotes are a big deal. So, be careful there. What transformations do you have? You got an A, a B, and a C here. What's our A value do? Vertical stretch by 2. What's our B value do? That's the C value. Is left 5. That is a transformation, but I started writing it. The B value is negative, so it reflects the y-axis or a HR. Okay? So, what's your vertical asymptote? Vertical asymptote, what is it? What?
X minus 5.
X equals negative 5. What's your HA?
Y equals 0.
Y equals 0. Again, there's a plus 0 right there. Okay? And then get your points and your domain and range. So you're going to have a transformation graph. I think there's just one transformation graph to actually graph on your practice for today. But then we need to talk about some more definitions. And again, this is just going to make next class not as miserable as it has to be. So, like, let's work a little more now so that way next class isn't as terrible. Okay, flip over. Back to the vocab. Back to the vocab. So up until this point, please stop talking. Please stop talking. We've been in transformations, okay? So before this, we were dealing with our transformation form, which looks like this. Y equals, we would have A over B, bless you, X minus C plus D, okay? You're going to hear me talk about transformation versus, I think I call the other one rational form, a lot over the next few days. But in transformation form, really what you need to know, your asymptotes, you can see right there and there. The graphs are not super crazy. There's not as much that goes on with transformation graphs as the other ones. But to get our minds ready to handle all of the information that will be presented to you next class, because it is going to be a lot of information to sort through. It's not difficult information to do, but it's a lot to sort through. We're going to go ahead and talk about what it looks like, what these attributes are, and what they look like on a picture, okay? So we've already discussed intercepts, okay? We will talk more about those next class, but on a graph, intercepts are not hard to find. My Algebra 1 kids should be able to pick out an X and Y intercept, even if the graph's crazy and you haven't seen it before. Where do they cross? Okay. Again, with x-intercepts, you can have, can have none, 1, 2, etc. Okay. You can have a couple x-intercepts, or you can also just not have any. With y-intercepts, there will only be one, if any. So we'll say can have none or 1. Okay, you can't have multiple of those, but there could be a possibility, depending on where your asymptotes are, that you don't have a y-intercept. The asymptotes, again and again, I will tell you, are very, very important. We will talk more about how to find these next class if they're not in that transformational form. Because again, if they are in the transformational form, you see them. If they're not, there's another thing you have to look at. It's not hard. It's just something you have to learn. Horizontals, hey, vax. I'll write that again. HA is y equals, VA is x equals. Okay? And those will be numbers. Domain and range. We really won't talk about range from here on out. I won't ask you to find it on a graph per se because there are some just special cases. So I'm just going to put a little star by that because, again, it depends on the graph with those. But here's the new words. Oh, I'm going to draw an arrow from vertical asymptote to domain, okay? Because that's one thing. That's part of your domain restrictions. So the restrictions on your domain can be vertical asymptote, and there's one more, okay? The restrictions on your range, I can't spell, can be your HA, and again, I'm going to put a little asterisk by that because that's sometimes, and then there's another restriction on the range, okay? And that's why, because of that little asterisk right there, that's why we don't really ask you to find it too much because it depends on the graph. There are going to be cases, and we'll see a picture of it today. We'll talk more about the algebra behind it next class. There are going to be cases where you do not have a straight horizontal asymptote. You have what's called a slant asymptote, okay? So that's more of an asymptote that is like a linear function as opposed to just a straight across horizontal line. This is something that's more of a pre-cal thing. We'll show it. We'll talk about what it means. We're not going to be finding it. If you do want to find it, long division is the answer. Okay? But we'll see that there. Okay? And then the other thing in the graph is called a removable discontinuity. Is the formal way. Removable discontinuity. That is what y'all were freaking out about earlier. That's a hole in the graph.
Oh, great.
Okay? Literally a point. It is a point on a graph that is undefined, and it's not a part of the graph. It is an open circle. You will be drawing an open circle on there, but it is a domain and range restriction. Okay, so put that here. Removable discontinuity affects your domain. Vertical asymptotes are restrictions, as well as x values of a hole in the graph. And then the y value, because it's a point, would cause a restriction on the range. But I'm not going to ask you to find that, okay? We'll talk about algebraically what's happening, but I'll give you just a little hint on this, okay? Let's say you had a rational graph equation, and it looked like this. X plus 4, x minus 5, x minus 3, x minus 5. Okay, let's say you just did your last test and I gave you this. What would you do if I said simplify it down? You would cancel this out because they're a common factor right there. Okay, but that was there in the original problem, right? So even though it can simplify down, it is there originally. So what would you tell me were the domain restrictions? What can x not equal? X cannot equal, no. It's in the denominator. X cannot equal 3. What else can x not equal? Cannot equal 5. Okay, so let's talk about the difference here. Did x minus 3 in the denominator cancel out with anything? No. This would be a vertical asymptote. That factor that didn't cancel. The factor that did cancel, that disrupted, is a domain restriction, but it has a common factor in the top and bottom. That's a hole in the graph. So that's algebraically what's different between the two. So they're both going to give you denominators of 0, and that's why the graph can't happen there. but it depends on if it has like a matching factor in the top, whether or not it defines it being an asymptote or a hole, okay? And we'll talk a lot more about that next class, but I just want to get your brain like kind of understanding like, hey, this is the vocab, this is what can happen. And now what we're going to do is we're going to look at 4 graphs, just kidding, 5 graphs, and just these are what they can get to, okay? They can be pretty basic, like these first 2, okay? Yes?
Why do domain restrictions exist?
Why? Because you can't divide by 0. Functions are undefined when you divide by 0. So anything that's going to make a 0 happen in here is going to give you a problem. And it just depends, it really depends on what's going on in the numerator, okay? So they can be pretty basic like this. I will help you with your asymptotes because this first page, page 5, they're not drawn in. As far as finding, because you need those. As far as finding your HA, just kind of find where the graph is like leveling off towards, and then just kind of draw a line in the middle. So it looks like this first one, I would say the HA is at, how do you write it? Y equals 3, okay? And then your vertical asymptote, that's where you look at where you're kind of going up and down on the graph, and I would draw that in, and I would say that's at x equals 4, okay? And sometimes this stuff isn't pretty. Sometimes you're going to have to kind of guesstimate, like for the x-intercept, okay, that one's not bad. What's the x-intercept? 2, 0. The y-intercept, I don't know, what are we going to say, 1.5? 1.5. 0, 1.5, okay? And then is there a hole in the graph? Yeah, that's like really large. But that can be it's an order pair. And that's happening at -3 is the x value, and then 2 is the y value. And again, on some of these, you're going to have to kind of just like do your best to guesstimate them. And then you can go from there. With the domain, real quick, remember, you've got 2 things that can cause restrictions. What is one thing that x cannot equal? 4, because that is a vertical asymptote. What else can x not equal? -3. Why not -3? Because that's the hole in the graph. Okay? So watch out for those. If there is a hole in the graph, it's going to cause a domain restriction. Do you have a hole in the next one? Nope. No. So you just say none. And then move on with that. You're going to come back and fill this out. Flip over real quick, though. This is this one right here, this is a slant asymptote. This is a slant asymptote. So there is actually not a horizontal asymptote because there's a slant. So that's not something that we'll be graphing in this class, but it is possible to see, hey, there's not one. This one right here, what's your horizontal asymptote? Where's your graph leveling off towards? Yeah, 0. Y equals 0. But if you look at it in the middle right here, you cross over that HA. That is possible. Between 2 vertical asymptotes, crazy stuff can happen. So it is possible to technically cross an HA. You will never cross a vertical asymptote, though. How many vertical asymptotes do you have here? You have 2. X equals -1 and x equals +1. And again, you can fill out the rest there. And then this next one, again, I would draw these in. You do have 2 vertical asymptotes. This time, the little middle piece of your graph doesn't cross over the HA. But we just kind of wanted you to see like all the possibilities of what can happen and just practice identifying the stuff from there. And if you have to kind of, like I said, guesstimate, that's okay too. Okay? I don't think there's any holes on this page. I think these are all nones. None, none, none. So fill out these information, and then when you're done with the notes, you can come get your practice packet. There's not a lot of problems for today. I think there's 1 transformation graph and then 4 graphs to identify stuff from. So you should be able to get that done. Hi, you are going to have a couple questions on your test that ask you to find the attributes from a graph that's already there. So they should be easy. They should be easy. So these are all star-worthy questions. Okay? When you're done with the notes, grab the practice and get 9 point, whatever. Are we in 9? We're in 10. 10.1. Get that done because it's short and fast and that'll be good.